The significance of taking an ultrasound machine and pushing it onto a chip is first and foremost about cost. We are able to make ultrasound machines much more accessible than they've ever been before because we leverage this sophisticated, inexpensive, high-performance supply chain that has fueled the consumer electronics revolution. And we're able to exploit some tremendous performance benefits to making ultrasound machines on this semiconductor platform. We can engineer these chips to have a much wider bandwidth than a traditional piezoelectric transducer, and that means that we have one probe that can look anywhere inside the body. We're actually able to not just put transducers on these chips, but a lot of signal processing and computational horsepower. And that means that we can do advanced signal processing techniques that you wouldn't otherwise get unless you paid way over $100,000 for an ultrasound machine. And we can show you that image on an iPhone. The way these chips are made is they start out with these large circular discs. We figured out how to etch almost 100 ultrasound machines onto one of these large circular discs. And these discs are run through hundreds of processes in incredibly complex, sophisticated factories that already exist. The same factories that are being used to produce the chips in your iPhone, the chips in your computer, the sensor for your digital camera. We use that supply chain and we use it to make a life-saving ultrasound machine. That little rectangular chip is the ultrasound machine. It has over 9,000 little drums on it that wobble to create sound and then receive it from the body. It does the computation to render an image. And when you look at our probe, the very front, behind the lens, is that chip.